Today our topic is density. Density is a property of a substance. Mathematically defined, density is the relationship between an object's mass and its volume. We can identify a compound based on its density. So density is an identifiable property. And we generally describe something's density in relationship to the density of another material. That material that's most commonly used is water. So the density of water is said to be approximately 1 gram per milliliter, but there are some special conditions on this density. It's 1 gram per milliliter at 20 degrees Celsius and 1 atmosphere of pressure. So we look at density in terms or in relation to the density of water. Now water is a very, very common substance. When we have water, if we have a density less than 1, typically something is going to float on top of the water. If the density is greater than 1, something is going to sink. A good example that we can look at that comes from the movies is whenever someone is in some kind of trouble with somebody who's probably not above the law, makes a pair of cement boots for them. What happens whenever they get a pair of cement boots? Well, typically they drop them off the end of a pier and they sink. Why do they sink? Because concrete or cement is more dense than water. Can concrete ever be less dense than water? Yes. Concrete can be less dense than water by changing the volume of the concrete. Another good example is steel. Steel is more dense than water. If I have a piece of steel, and I think I might have a little piece here, and I put it in some water. Okay, let me get some piece of steel. Here's a piece of steel. If I put it in water, what's going to happen to that piece of steel? Well, it's going to sink to the bottom. Okay? Now, out at the shipyard, they make boats out of steel, very similar to this kind of steel that's sitting at the bottom of my beaker of water. Now, would we want our boat that we just paid millions and millions or billions and billions of dollars to come off of the dock out there and sink to the bottom? No. It's made of the same material, so what do we have to do? We have to change the volume of the steel so that the steel floats. Okay? So we increase its volume or its water displacement. But in chemistry, we're just going to look at the concept of density and how it relates to chemicals. So, our mass is typically given to us in grams, and our volume is typically given to us for a solid or a liquid in milliliters. Okay? If we're looking at a gas, we're going to say solids and liquids. If we're looking at a gas, our density is typically given to us in terms of grams per liter. Why the difference? Because a gas is very, very dispersed particles. And they have a very, very small mass for the number of particles that we have. So we tend to look at it in terms of a larger volume. Now, if we have two liquids of different densities, I've got my beaker here, and this is just tap water, okay, and we still got our piece of steel from the boat sunk down at the bottom of the beaker. If we add to this beaker some vegetable oil, okay, now vegetable oil has a different density. So what's going to happen, or what do you predict is going to happen to the vegetable oil? Do you think the vegetable oil is more dense or less dense than the water? Well, let's see. Hopefully it's not going to mix. Hopefully it's going to do what it's supposed to do. And we're going to add some oil there. Okay. Now we have vegetable oil on top of, or added to the water. Okay. We're going to let it settle because I let it pour in a little bit too quickly. And we'll see what begins to happen. Okay. We'll see what begins to happen. In our beaker here, we begin to get two layers. Can you see the two layers? Okay, I'll bring it a little bit closer so you can see the two layers. Here we have a layer of water. Here we have a layer of vegetable oil. So what does that tell us about our vegetable oil compared to our water? Is it more dense or less dense? It's less dense because it floats on top of the water. Now I have another beaker here with just some more plain water. So let's look at some other substances in addition to the vegetable oil. I've got a rubber stopper here. I'm going to put the rubber stopper in. What do you think is going to happen? More dense or less dense? Well, it sinks, so it is less dense. I have a piece of a wood dowel. Okay? It's a small piece, so I'm going to bring it a little bit closer. Put it in, and what does the wood do? Can you see? The wood floats, but yet the rubber sinks. I've got some different types of materials here. I have some plexiglass, like you have for a window, for a plexiglass window, and I put it in, and it sinks. I've got various other types of plastic. I put them in, and they sink. So out of all the materials I have, the only one that seems to float is wood. If I had a piece of cork would float higher than wood because it would be even less dense than the wood would be. And the difference between the cork and the wood is that the cork has some embedded air pockets. It's not as closely connected, all the wood cells are as in a piece of a dowel. So the wood cork would float a little bit higher. Now, in addition to density, sometimes we come into contact with a term called specific gravity. Specific gravity. Specific gravity is simply the relationship between the density of an unknown substance and the density of water at the same temperature and pressure. So what does that mean? Well, it simply means that specific gravity is nothing more than density without units. So where do we see specific gravity? A lot of times we look at specific gravity in terms of concentration. Because in terms of concentration, we could look at it in terms of percentages, molarities, normalities, or we could just come up with a unitless number based on the density. The most common place I believe most of us will see at this point in our lives for specific gravity is in the concentration of antifreeze in your car. The concentration of antifreeze is measured in your radiator with a hygrometer. Okay, a hygrometer is a tube. It looks like this. Okay. I'm not an artist, so maybe it looks a little bit better like this. Okay, and there's a little ball floating around here that weighs a certain amount, and there's graduations up the side. You suck some liquid up in your hygrometer, and the ball floats based on the relative density or the specific gravity. And that specific gravity is related to concentration. So we've got two terms today that we've looked at. We've looked at density, which is the mass-volume relationship. If we're looking at solids or liquids, we're looking at it in terms of grams per milliliter. If we're looking at a gas, we're looking at it in terms of grams per liter. We've got the concept of specific gravity, which is simply density without any units. Now let's look at working a problem, okay? And see if we can answer a question after we have worked this problem. Okay, I have a piece of metal. Okay, I've got a piece of copper. Okay, that copper has a mass of 16.46 grams. It has a volume of 18.84, not grams. Volume would be in milliliters since this is a solid. Okay, So my question is, what is the density? And would it float in just regular tap water? Okay, well, first off, I've got to set up my density equation. So density is mass over volume, so that would be 16.46 grams over 18.84 milliliters. So if I get my calculator out and do a little bit of math, 16.46 divided by 18.84 gives me a density of 0.8736730,361. But I know that I've got to have in the correct number of significant digits. I have 4 digits here, 4 digits here, so I need to round my answer to 4 digits. So that would be 0.8737 grams per milliliter. That's my density. My first question is answered. My second question is, does this piece of copper float? Well, to answer that, I need to know that the density of water is 1.0 grams per milliliter. This is more than 0.8737 grams per milliliter. So the density of water is greater, so the piece of copper floats. Okay? Okay, that's our lesson today on density and specific gravity.